Alright, we're going to do 3 together. I'm going to space this out here. Somebody might need to pull up my solutions. I might need to get my solutions out so make sure I'm getting the same answers. Alright. Okay. Alright. Okay. Alright, so the nice thing about number 3 is it gives you the answer to A. So, yeah. Okay, but you have to know how to get that and show the work because obviously it's not just getting the answer since they gave you the answer, right? So they're saying show that dy over dx equals this. So you have to show the work, but you should get this answer at the end, okay? So we're starting from x y squared minus x cubed y equals 6. And we're going to take the derivative. This is going to be a implicit differentiation. What do we have to use when we take the derivative of x times y squared? We're going to have a dy dx, but also the product rule. So x times the derivative of y, which is 2y dy dx, plus y squared times the derivative of x, which is 1. Now that's just the derivative of this first part. Now I have to take the derivative of the x cubed times y. Again, I have to use the product rule again. And what messes most students up here is this negative needs to be distributed to everything. So I'm going to put me a bracket right here for where I take this derivative. So I'm going to have x to the third times the derivative of y, which is just dy dx, plus y times the derivative of x cubed, which is 3x squared. Not 6. 0 because we're taking the derivative. So, we can distribute this negative here, and we'll have 2xy dy dx plus y squared minus x cubed dy dx plus, oh no, minus, thank you, minus 3x squared y. What do we do after we've cleaned this up a little bit? What do we do? Everything to the other side that does not have a dy dx. So, and I'm going to go ahead, I think it's alright if you do this, I'm going to go ahead and factor out the dy dx while I do this. Thank you. Oops. So when we move this stuff over, it's going to change sign. Oh, mess that up. Another thing is, like, you want it to look exactly like this at the end. So I could put the negative y first, but I'm going to do the 3x squared y first minus y squared there. And then the last thing we're going to do is divide. So our derivative is going to be 3x squared y minus y squared over 2xy minus x cubed.
So getting points on that would just be showing that.
Right. Right. And your work is your answer here. Obviously, you want it to be exactly like this. And like I said, it needs to be exactly like what you have here. So, like, if for some reason I had written it like this, negative y squared plus 3x squared y over 2xy minus x cubed, If I had it written like that, I would want to write it down exactly like it is here.
So you just start by writing the answer.
Yeah, even though these two are equivalent, I want to make sure that it looks exactly like this. You don't want to stop early, right? And let's say that you don't know what you're doing and you've messed it up. Just make sure at the end it equals something they might assume you knew how to do something that you didn't really know how to do. Probably not, but they might. So make sure you get that answer at the end. You might not get any points, but if you don't get to that answer, you're definitely not getting all the points.
Especially if it gives you the answer.
Yeah. Another thing about questions like this, because they do this often on implicit differentiation, and the reason they do it is because if you get the implicit differentiation wrong, then part B and C you're going to get wrong. So they do this a lot. So on parts B and C, if you were to get a different answer, don't use it. Use what they told you the answer was, right? That's what you're going to use for parts B and C, even if you didn't get that whenever you solved it, because they are definitely more right than we think we are, right? So they're like, AP has a lot of money because it costs a lot of money to take those tests. So, and everybody in the whole country and outside of the country takes AP tests. So they're making, like, for you guys, the state covers it, which is good. But, you know, like, you could go pay to take tests. Like, somebody's paying for all of those tests. They have a lot of money. They hire a lot of people, super smart people, and they spend a lot of time developing their stuff. So if you see something like this on the AP exam, there's probably not anything wrong with the problem. Now, if I created the problem, that's low budget AP questions right there, and there's much higher probability there could be a mistake. So if I created the problem, then there could be a mistake. That's straight from AP. Part B is straight from AP. I think, no, this all of question 3 is straight from AP test. Number 2, I think part C I made up myself because we couldn't do the real part C on that one. So, but I have worked out. I think that one's all right. Okay, questions? Okay, it says for B, find all points on the curve whose x-coordinate is 1 and write an equation for the line tangent at each of these points. All right, so we know that the x-coordinate is 1 and we're looking for tangent line. All right, what do we have to have for tangent line? Point, slope, and the equation, right? So it's the same thing even with this, but it's going to be a little more complicated. How do we find the points? One into the original function. In this case, it's not a function because it's implicit differentiation, right? So we're going to plug 1 in for the x up here. We're going to have 1 times y squared minus 1 cubed times y equals 6.
So you wouldn't do F of 1? You
Can't do f of 1, and you don't write any like notation like f of 1 because you don't have f of x notation in this. So that just show your work where you plugged it in, even though it is a 1, right? That you put the 1 in there so that they're following what you're doing there. So y squared minus y equals 6. How do I solve this? I need to factor, so I'll move everything to one side. And so we get a minus 3 and a plus 2. So y equals 3 and y equals negative 2. So here's what's different about this problem. We've got 2 points because you got 2 y values. So one of your points is going to be 1, 3. And then another point is going to be 1, negative 2. And notice it kind of leads you in that direction in the way the question's worded at each of these points. Sometimes they won't lead you. Sometimes they'll say, like, that there could be one or more, but they kind of lead you in this direction here this time. So, that's our point. How do we find our slope? Plug into the derivative, right? So, it's the same. Notation's a little weird here. We've done it a little bit, but we haven't messed with this notation a lot. dy dx such that xy equals 1, 3. And then we're going to plug in 1 and 3 for our x and y. So we'll have 3 times 1 squared times 3 minus 3 squared over 2 times 1 times 3 minus 1 cubed, which is going to give us 9 minus 9 over 6 minus 1. So we get 0 over 5, which is 0. Now, when you have a slope of 0, you can still use point slope form if you want. You could have 0 times x minus 1 plus 3. So you can write it like that. That's perfectly fine. Or you can do y equals 3 on that. So make sure I've got that part right. Yeah. Yeah. So you can leave it right here just like we would normally. It's just that 0 times that stuff is just going to be 0, so it's just going to be y equals 3. Or if you notice, obviously if it has a slope of 0, it's going to be a horizontal line, and horizontal lines have equations of y equals the number. It's going to be y equals that y coordinate. You could do it that way too. What is important here is that you show that you are plugging that point into this derivative. Technically, you don't even have to simplify, but in order to write the equation of tangent line, you're going to want to simplify, and then that you put that into the equation line. Okay, we got to do the same thing for the other point now. So again, that notation, dy over dx such that xy equals 1, negative 2. And so we'll have 3 times 1 times negative 2 minus negative 2 squared over 2 times 1 times negative 2 minus 1 cubed. Negative 6 minus 4 over negative 4 minus 1. Which will give us negative 10 over negative 5, which will be 2. And then so our equation of our tangent line here is going to be y equals 2 times x minus 1 minus 2. It is important here to make sure your work is organized so that I can follow what you're doing. You don't want to go all over the place. It needs to be very clear that this work goes together and clear that this work goes together. So please do not write sideways, upside down, put stuff here, 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 Daniel. Okay, questions? All right, let's look at C. Okay, and there's also a similar part, like, this is really typical for you to see on implicit differentiations. You'll notice part B on number 2 asks basically the same thing, right? The equation of each vertical tangent to the curve. Down here, we're supposed to find the x coordinate of each point on the curve where the tangent line is vertical. So vertical tangent line is what we're looking at here. So vertical lines, what can you tell me about their slopes? Undefined, right? So the denominator is going to be 0, right? Because if we have a number over 0, it's undefined. So we're going to take the denominator of our derivative, 2xy minus x cubed. And we're going to set it equal to 0. Here's the problem. It's got an x and a y. So, we know that this would have to be true, right? We also know x and y are points on the original equation, right? So this has to be true for us to have a vertical tangent line. And for this particular problem, it always has to be true that xy squared minus x cubed y equals 6. So, even though I can't solve this equation with an x and a y, way back, we probably didn't do it too much in your other classes, but way back in Math 1, we did systems of equations where we had two different equations and then we figured out how to find the answer for where they crossed, right? So that's what we want to do here. These are just way more complicated than y equals 2x plus 7. So this is the original right here. And so that will always be true for every point on that curve, right? Because that is the definition of the curve. So we know that this is right. So the denominator of the derivative, we're putting it equal to 0 because it's a vertical tangent. So at the point we're looking for, that has to be true. It also has to be true that it's on this curve, right? So this has to be true for any point on the curve. So both of these statements right here have to be true for this situation. Yeah. So whenever you were doing systems of equations, we did elimination, and that's where we lined up like our x's and our y's and our equal sign. Is it going to work to line up your x's and y's and equal signs here? No. Because you got this. So the other thing that we used was substitution, which is where we solved for one variable and then plugged it into another equation. Okay, so we could solve for y right here. So 2xy would equal x cubed. We'd have to divide both sides by 2x. So y would, this is like it's a 1 right here. So we have one of these x's is going to cancel. So we'll have x squared over 2. You can think of it like that, or you could do 1/2 x squared. Move your 3x over, divide by 2x. Yeah, I just reduced there. So now we can take this and replace our y's in our original equation. This is substitution here. Advanced substitution. Okay. All right, so you're going to have x squared over, it's going to be x times x squared over 2 minus x cubed times x squared over 2 equals 6. Did I have it wrong? Written wrong? The y is squared. Oh, yes, this is squared. Yes, thank you. There we go. All right, so This is like x over 1. You need to do order of operations. So what should you do first? Exponent first. So x over 1 times x to the 4th over 4. Yes, but you can't do anything inside of those parentheses. So if there was anything we could actually do inside those parentheses, we would do that first. But we can't, x squared divided by 2, we can't simplify. Yes, when we square a fraction, we square the top and the bottom. And so this is going to be x to the 5th over 4 minus x to the 5th over 2. It's convenient there. We're getting both of these are x to the 5th. Okay, so think of this as 1/4 x to the 5th minus 1/2 x to the 5th. You can do it that way too. Yeah, because like we got a 1 right here, so we could just multiply it over to the side because it's like multiplying by x to the 5th over 1. And so if I'm doing 1/4 minus 1/2, what am I going to get? Common denominator, so 1/4. You're right, it's negative 1/4. They just sounded like they didn't know how to get that later. So 1/4 minus 1/2. Common denominators, 1/4 minus 2/4 equals negative 1/4. You don't have to show that. Negative 1/4 x to the 5th equals 6. Yeah, I'm just combining those two terms because they're both x to the 5th, so we can combine those. Okay, how do I get rid of the negative 1/4? Multiply. I'm going to just go ahead and multiply by a negative 4 here. So x to the 5th equals negative 24. Take the 5th root. You can, but I would not mess with it. I would just leave it like that. Actually, no, I'm sorry. That is false. No i's. What does I mean? Square root of negative 1. Not the 5th root of negative 1. Can you take the 5th root of a negative number?
Yeah.
You can, because it's an odd root. So 3rd roots, 5th roots, 7th roots. So this is not imaginary here. This is a real number. Yeah, so you have a vertical tangent here. It is okay just to leave it like this. You don't have to summarize with words. So you could leave it. Yes. 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 You have to get to this because that x has to be by itself. You have to be solved for x, but you don't have to simplify that 5th root of negative 24. So and it does not simplify easily, so just leave it like that. Yes, this is the x-coordinate where you have a vertical tangent. And it is what it asks for. It does not ask for the y-coordinate, thank goodness. If it had asked for the y-coordinate, how would we find that? Plug it back into the original for x and find the y, but thank goodness it does not ask us to do that. It mostly probably doesn't ask us to do that because I don't think you can do that by hand. So. whichever one is randomly selected will be randomly selected. It's up to chance. I definitely do, like, I actually randomly select one. So,
One to three, let's select it right now.
well, then you'll know. It's got to be a secret. But I randomly select it, so whichever one,
Like, I didn't even realize.
yeah, whichever one we do in class has nothing to do with whether or not it will be on there. So, very often I have chosen the one that we did in class. But it just depends. What's that? Probably not. I mean, I definitely think you should be able to do A on your own. Yeah, part A. Part B. Part B, I think you guys, because we have not done a lot of this, like our textbook gives us both coordinates most of the time. It gives us like 1, 3, or 1, 2. So I think you guys may have had some trouble figuring out these points, but once you've got the points, I would expect you to be able to do the lines on your own, no problem. And part C, would not really expect you to be able to do on your own without seeing it. But now that you have seen it, I would expect you to be able to do that or something similar. It would probably be a good idea to take part C there and tonight go back and try to do it on your own without looking at what we've done here, because it's kind of tough. Okay, questions?
Yeah. Is the whole reason you chose just because they were true, or they related in some other way?
Well, I mean, this is true for every single thing, so we could use it for any question they asked us. It's true for this whole problem. This is the denominator of the derivative set equal to 0, because a vertical tangent line is going to have a 0 in the denominator. So the denominator, this is the piece that gives us the vertical tangent line. This is a piece, like this is true for everything. That's why up here we plugged 1 into that original equation up here, because it's true for everything on this problem. Right? Okay. The solutions should be up. I believe they've been up for a while, so you can check your work as you